In this video we are looking at the solutions to questions 12 to 19 on the Corbettmaths worksheet applying limits of accuracy. With question 12 it says Kelly drove a distance of 120 miles to the nearest 10 miles in a time of 2 hours to the nearest hour. Work out the difference between Kelly's greatest possible and lowest possible average speed. So as with the majority of these sort of questions, you need to first of all work out the limits. So we look at the 120 miles, and this is to the nearest 10. So if it's to the nearest 10, the lowest limit, the lower bound will be 115. That's half of the 10 that we have for the nearest. And 125 will be the upper limit. Anything over 125 would round up, anything below 115 would round down. And then for the 2 hours, we have 2 hours, and this is to the nearest hour. So I halve that hour to make it half an hour. So my lower bound will be 1.5 hours, and my upper bound will be 2.5 hours. Again, anything above 2.5 hours would have rounded up to 3. Anything below 1.5 hours would have rounded down to 1. So these are my limits. Now, how do I use them? The question talks about the greatest and least and lowest average speed. Speed, as you know, speed is distance divided by time. So I want to look at this formula and go, how am I going to get to the greatest value and how am I going to get to the smallest value? Well, to get the greatest value from a fraction, the numerator has to be the biggest it can be, and the denominator has to be the smallest it can be. That would give me the greatest value. So, speed greatest would be the biggest distance, 125, divided by the shortest time, 1.5. Putting that into a calculator, I'm going to get 83.3 recurring, and that is miles per hour. Now let's do the speed lowest. So for the lowest value from a fraction, I want the smallest numerator and the largest denominator. So the smallest distance is 115, and the greatest time is 2.5, and 115 divided by 2.5 is going to give me 46. Checking the question, it says work out the difference. So the difference is just going to be one subtract the other. So it's going to be 83.3 recurring, subtract 46. And that's going to give me the answer of 37.3 recurring miles per hour, which can be written as MH or MPH. With question 13, there's an awful lot of words here, and it appears to be a very, very complicated question. What it will involve is doing pretty similar operations multiple times. The important thing to note from this question here is the last line. It says work out the upper bound for the amount of money. So we're only dealing with upper bounds. We do not need to consider at all any of the lower bounds for this particular question. So let's look at the strawberries first. So strawberries, we have 4 kilograms of strawberries to the nearest kilogram. So that means that she could end up buying 4.5 kilograms of strawberries. That would be the upper bound. And the cost of the strawberries is £1.20 to the nearest 10 pence. So the upper bound of that would be £1.25. So we're looking at 4.5 times 1.25. The maximum she would pay, the upper bound of what she would pay for the strawberries, is going to be £5.63. It's actually £5.62.5. We'll round it to the nearest penny. Let's look at grapes. Now, grapes. she buys 3 kilograms to the nearest kilogram. So again, the upper bound of that will be 3.5 kilograms. And grapes are £1.30 to the nearest 10 pence. So the upper bound of the grapes will be £1.35. We take our 10 pence, we half it, and we add it on. So the cost of the grapes, the maximum or the upper bound of the grapes is going to be 3.5 multiplied by 1.35. And that's going to give us an answer of £4.73. It's actually £4.72.5, but we'll round it to the nearest penny. Now let's look at the final one, which is apples. So she buys 50 apples to the nearest 10. So that means she could, in total, buy 55 apples. That will be the upper bound of the apples she buys. Apples cost 20 pence to the nearest 10 pence, so she could pay 25 pence per apple. Half of 10 pence is 5, you add that on to the 20. So 55 times 25, bearing in mind that's pennies, not pounds. So on the calculator, 55 times 0.25, she will spend a maximum of £13.75. So we want the upper bound for the amount of money. So the upper bound for money, upper bound, we'll call it bound total, will be just these numbers added together. So we've got 13.75 plus 4.73 plus 5.63, and then we get the answer of £24.11. It's important to note that the answer I've given here is different to the one published on the Corbettmaths answer sheet. They've actually published £23.31. I'm confident that my answer is correct. If you can see where the error is, if there is an error in mine, please let me know. But as far as I'm aware, I'm pretty confident that this is the correct answer. So this question here involves significant figures and rounding with them. So let's have a look. It's a little bit different from the previous ones. We have a circle which has an area of 600 centimeters squared. And this is correct to two significant figures. So let's think about it. The two significant figures would be the first two non-zeros, so the 6 and the 0. So the one above that to two significant figures would be 610. And the one below that would be 590. And just stop for a second and look at that. So we're doing to two significant figures. At some point between these two numbers it rounds up to 610. And at some point between these two it rounds down to 590. So where are those points? Well, they're going to be exactly halfway. So halfway between the two on the right, we're going to have 605, and on the left, we're going to have 595. What that means is, once we get to 605, if we rounded that to two significant figures, it would go up to 610. If we rounded 595, it would go up to 600. So those two numbers in red are the bounds. So we have 600, which is less than 605, greater than or equal to 595. Okay, and it says work out the lower bound of the radius. So what's the formula for a circle? Area of a circle. Area is pi radius squared. So we want this to be as small as possible. Well, let's just rearrange that formula. Let's actually get it to a form that we can use for the radius. So radius squared is going to be a over pi. So the radius is going to be the square root of a over pi. The only variable here is a. Pi is a number, as you know. So for this to have its smallest possible value, we want the smallest possible area. So that's 595. So what we will do, if we do radius lower, it's going to be equal to the root of 595 divided by pi. So 595 divided by pi, that's going to give me the root of 189.3 0.39. If I square root that answer, I get the answer of 13.76. I'll go to two decimal places, should be fine, and that's centimetres. Question 15, W equals AT, so we're given the formula, we don't know what it means, we don't need to know what it stands for. And it says that the variable A is equal to 15 correct to 2 significant figures, and W is equal to 700 correct to 2 significant figures. Calculate the upper bound of T. I'm going to do this by looking at the formula first, because hopefully this will actually make my workings a little bit easier. So I've got W equals AT, and I'm looking for the upper bound of T. So what is T equal to? T equals W over A. And I want the upper bound. So the upper bound is going to be found by making that fraction as big as possible. So the upper bound will come from having the largest possible W, so W upper bound, divided by the smallest possible value of A, so A lower bound. That combination will give me the largest possible value for T. So let's look at W. W is 700 to 2 significant figures. So in the same way as I did it in the last question, 2 significant figures going above will be 710, and I want the boundary being halfway between those two. So that's going to be 705. So 705, as you know, would round up to 2 significant figures to 710. So I'm going to use 705 as my upper bound for W. So that's 705. Now let's look at A. A is 15. I'm going to put it, where am I going to put it? Over here. A is 15. And I want the lower bound for this one. So 2 significant figures. If that's 15, then the lower one would be 14. Halfway between that would be 14.5. So 14.5 to 2 significant figures would round to 15. So 14.5 is the figure I'm going to use for my lower bound here. Let's put this into my equation. So T upper is going to be 705 divided by 14.5. 705 divided by 14.5, and that's going to give me an answer of 48.6. And I've put that to 1 decimal place. I think you need at least 1 decimal place. Preference might be going to 2, but that should be good enough for the question.